Good afternoon, Mr. Eddie Fong, Chairman of the MPMA Plastic Month 2021 Organizing Committee and Secretary General of MPMA. Distinguished speakers and participants, welcome to the fourth webinar in the MPMA Plastic Month 2021. Today's webinar is entitled Sustainable Flexible Packaging Trends 1. To begin, let me run through the etiquette or rules of the webinar. You will notice that we have muted and turned off video for all participants. This is because we are using a conference platform on Zoom, and this feature is activated to ensure no disruptions to the speakers during the webinar. Participants may ask or post questions related to the presentations in the chat box during the webinar. The speakers will only answer questions that are clearly written and based on the presentations. Kindly refrain from marketing your goods or services in the chat box. Kindly also refrain from posting comments or remarks to questions posted in the chat box. The chat box is only for queries related to the presentations. The organizer reserves the right to remove participants who run afoul of the webinar etiquette. The MPMA Plastic Month 2021 is brought to you by MPMA with the generous support of sponsors from the Malaysian plastics industry. Please allow me to thank each and every one of them. Our exclusive platinum sponsor, Monitor ERP System. Gold sponsors, PT Pops Jakarta, American Asia Private Limited, NGR Malaysia Sdn Berhad, Petronas Chemicals Group Berhad, Rivenhauser Brunfirm GmbH, and Windmoller and Houses Asia Pacific Company Limited. Silver sponsors are Albert Sdn Berhad, Not Mechanicals SPA, and Sys4 Software Malaysia Sdn Berhad. Our bronze sponsors, Autotest Malaysia, Ben Mayer Specialties Malaysia PLT, Boros Private Limited, Husky Injection Molding System Malaysia Sdn Berhad, Recommend Malaysia Sdn Berhad, Sigma Soft Sdn Berhad, and Torre Plastics Malaysia Sdn Berhad. We have one other sponsor who is Krybert TPE Technology Malaysia Sdn Berhad. A big thank you to all our sponsors for making the MPMA Plastic Month 2021 a reality. In appreciation to our platinum sponsor, Monitor ERP Systems, for their contribution towards the event, we now play Monitor ERP Systems corporate video. Thank you, Monitor ERP System, and Mr. Daniel Hedmark, who is the Managing Director of Monitor ERP Systems, for his support towards the MPMA Plastic Month 2021. Ladies and gentlemen, without further ado, let me introduce to you our moderator for today's webinar, Mr. Elvin Ang. Mr. Elvin is the Chairman of MPMA Northern Branch and Executive Director of Tongguan Industries Berhad. Mr. Elvin has been MPMA's Northern Branch Chairman since 2016. He is the Executive Director of Tongguan Industries Berhad since 2013. He was instrumental in planning the listing of Tongguan on the Kuala Lumpur Stock Exchange and has contributed immensely to the growth of Tongguan since in the field of finance, taxation, IT, project planning, and implementation. As many of you know, Tongguan is one of the largest producer and exporter of stretch film in this region. It gives me great pleasure to present our moderator today, Mr. Elvin Ang.
Thank you, Mr. Chan. Without much ado, I would like to introduce our first speaker for today. He is Mr. Senor Francesco Silveira. He's currently the Sales Area Manager of Colonies SLPR. He joined Colonies in 2018 with a background of a bachelor's degree in management engineering and a master's degree in management engineering in innovation and product development from Polytechnic University of Turin. Mr. Senor Silveira, the floor is yours. Thank you.
Hello, everyone. Thank you, Mr. Ang. So I will start with my presentation. Hello, everyone. I am Francesco Silveira from Colines, and today I will talk to you about the evolution of the flexible packaging market from PE to MOP. My company is an Italian company in the production of plant for the production of stretch film, breathable film, MDO films, air bubble film line, and also for blown film lines. We are situated all over Italy, and we have also one company in the US for the service operations. I want to start to present you some number from the film future of the MDO films, in particular with the study with our consulting society that studied the MDO film process and the MDO film market through next year. So in this slide, we can see what can be the annual growth rate. This is the annual growth rate, this percentage right here, for next year for MDO films in cast film lines and blown film lines for the next years. So here you can see the growth rate through years, both in terms of kilotons and in US dollar. This is the annual growth rate by application. So we can see for bags and pouches will be the most annual growth rate, then shrink labels, shrink wrap, and so on. Also, for US dollar, we have the same growth rate through these years, from 2019 to 2027. Especially, as you can see from this slide, the Asia-Pacific region will be the one that have the most growth rate through these years, as you can see here. Also, in terms of cast film technology, so also for cast MDO film, the Asia Pacific will be the region with the most annual growth rate, as you can see from this slide. And for the blown film technology, way above the rest of the world. That being said, why Colines is focusing on the MDO film market. Here are some of the drivers that drive us to study and developing this technology. The demand for convenient packaging in food sector, because as you know, nowadays single portion are all over the world. Then there is the COVID pandemic. So we need in the food sector more packaging, as you know better than us. Then there is the rise in demand for higher shelf life products, the improvement of cost efficiencies and packaging performances of MDO films, and the booming on the healthcare and personal care industry. So this is the current situation in the PE market. There is great availability of commodities, product at low price, high competition between the major producers, low presence of CPE films because of the absence of an actual variety of suitable resins, and difficult to recover PET once coupled with PE. And this last point, I think, is the most important one, because in terms of waste and so on, we are in a period where recycling material is the most important things. Here we can have a typical PE-based packaging configuration, where we have the BOPET film that is printing, then laminated with PE film. So we have two types of film, the BOPET and the PE. This is the key feature of the BOPET film. So excellent printability thanks to its stiffness, excellent flatness and thermal stability with the consequent excellent workability in converting, excellent transparency and brilliance, then also some bad property like poor weldability, poor resistance to puncture, and difficulty to recovery once laminated with PE. Always, this is the most important point.
Sorry,
Obvious.
sorry, Mr. Francisco.
Yeah.
There's a slight issue with your slide. We couldn't see your whole presentation. It's like cut off at the sides. Are you able to perhaps stop share and reshare?
Yeah, I can try to do something, sorry.
Okay, thank you.
You still have this problem, yeah, right?
Yes, we still have the problem. Perhaps you could go back, exit the full screen. I think we can make do with just sharing the this. You just have to zoom in a bit, then it will be fine then.
I'm sorry for that.
No problem. I think that this will do, yeah. I think
Francisco, can you try to go down, if we look down at the bottom, click on that, no, this one more to your right. See whether it works on that. No, it doesn't work. Work. It's still facing the same problem of, because it doesn't fit into the frame of the screen.
Yeah, because I think it's in 69, but the presentation have to be made in different configuration.
Can you reduce the size? The sliding scale there, you put down 69%. Let's say if you bring it down a bit more.
Like this?
No, that's okay. Try that again. Yeah, a bit
like
less.
This.
No, a bit less. Some more. Okay, like now this. click on the full.
Okay, perfect.
It's still a bit, but it's better. I think just now go back to that and reduce further. Reduce further. Okay, click on that now. Okay, click on the.
Okay, I think this.
I think this looks better.
Okay, thank you.
Yeah.
Sorry. So, as I was telling right before, the PE film is laminated with BOPT, and with the PE film we have excellent weldability and weld resistance, excellent puncture resistance. When we have the CP film, we have good flatness and consequent workability in converting. And then we have also right here some bad points, like PE blown has medium flatness and consequent workability in converting, and poor printability due to not high stiffness. The main purpose in the MDO film market is the replace of the BOPT film to build an easy recyclable monomaterial packaging. Because as we know, we are going for green. So also Collins is studying something to produce MDOP film and make a monomaterial packaging that can be 100% recyclable. This is the new PE-based packaging configuration. So we have MOP film instead of BOPT, printing, lamination, and PE film. As you can see, now we have both PE-based film, so the packaging can be easily recyclable. In fact, the advantage of this new packaging configuration is the utilizing of a single type of polymer, the PE, easily to recyclable, single line that can produce both films, forming the complete packaging, because with the same line, you can produce the CPE and the MOPE by utilizing the MDO unit, and the possibility of reutilize online trim and edge from both films. For sure, this is one of the best points and the best key factor, because in our lines and in cast lines, you can utilize 100% of the trim in line and utilize as the virgin material. Here are some little, let me say, secret of our MOP film structure. We try on our machine the 5-layer structure with this type of configuration, so triple layer and so on. And also we have tried a 7-layer configuration that gave us better results with this type of configuration, as you can see right there. What about the raw materials in the processing of the MDOP film? The skin layer needs to be a material that guarantees thermal resistance in the welding operation. Subskin may contain material that have the stretching process, as well as the core layers. So core layers and subskin have to be material that can help the stretching process. This is the most important process in the MDO unit. What about the process? You need to have the best possible pre-MDO film, because any defect will be amplified by the MDO unit. And the film cooling process must be properly controlled to have a better stretching process. And you need high temperature in the MDO unit stretching section. Now we'll show you some of the current limit of the actual MOP blown production, because the production of MOP film right now is basically only in blown lines. And we have future that not satisfying in terms of transparency and planarity. We have limits in terms of productivity if compared with the cast line, for sure. Possibility to produce only asymmetric film, and a lot of production of trims that must be regranulated, so we have high cost, and the pellet is not good as the virgin material, for sure. What about the cast technology? Why Collins is developing the MDOP? Because you can have higher productivity and higher speed than blown technology, better transparency, better and stable control on the profile, and overall inline trim recovery without any waste. So trims are directly utilized in the MDOP production. Inline, this is inline recovery for sure. This is how it works, the MDO film manufacturing process. So we have the pre-heating section, orientation, that is the stretching section, annealing and cooling. Here you can see Collins MDO unit, where the film goes in this way, then entering the MDO section with the preheating section, when the film is preheated to achieve the temperature that is needed in the stretching unit. This is the core of the MDO unit, where the film is stretched and gain its properties. Final, the annealing section is the section where the film is stabilized and maintain the properties, and then the cooling section before entering the treating section and the winding section. Which has the advantages of the Collins MDO unit compared to other MDO units? The most important one is the IR heating with IR segments inside of the cylinders. I cannot show you because of our know-how, but inside of this cylinder you have a lot of heating section with IR segment that you can decide with your through your HMI that is placed beside the MDO how to heat up one single segment or all the segments to gain the film the best properties possible. Then we have very low energy consumption because of utilize the IR heating. No heating thermoregulation unit because is not a oiled or water-based MDO unit. And then no oil leaking because of for sure you don't have the thermoregulation unit. And finally, this is our lab line where we produced both CP film and MDOP film, and we already have some reels that we can share with our customer or who is interested with, and we also made some samples of printed MDOP film, and the results are very, very good, as you can see. Thanks for your attention. For any further information, contact us at InfoCollines or at my personal email, francesco.silvera@collines.it. Thank you for your attention.
Thank you very much, Senor Silvera. Next, we have another speaker from Italy, Senor Govinderjit Singh Gill from Not Mechanica. Mr. Senor Govinderjit Singh has been with Not Mechanica since 2019. He is currently the sales manager in charge of the Asia Pacific market. He obtained his Masters of Science Mechanical Engineering from Politecnico in Milano, in Italy. The floor is yours, Mr. Govinderjit Singh. Thank you.
Thank you. Thank you, Alvin. I hope you guys already see my screen. And here we are at the laminating, coating, and metallizing advanced technology for sustainable packaging. First of all, thank you. Thank you, the section chair, for giving us the opportunity to present during this event. And thank you to all the participants for their availability. Let's start with the Nord Mechanica background. Nord Mechanica is located 40 kilometers far away from Milan in Piacenza. And here in Piacenza, there is the Nord Mechanica headquarters. The Nord Mechanica headquarters incorporates 3 production plants where all our fully automatic high-performance customized lines are manufactured, and a 4th production plant, which is located 5 kilometers far away from the headquarters, where all our simplex compact lines are manufactured. Then the corporate incorporates the research and development department, the electrical cabinet mixer assembly line, the spare part department, and the engineering department. And here on the top, you see the Nord Mechanica vacuum divisions. Here you have some facts about Nord Mechanica. Incorporated back in 1978, we are over 300 employees in 3 locations and 7 plants. Plant expansion that take place regularly every year. In fact, for the 2022, we have already bought the land and we plan to increase our production capacity by at least 20%. Nordmechanica has a regular turnover well above 100 million euro distributed globally over a 70% of global market share. Apart, the Italian headquarter Nordmechanica is present with direct offices in the United States, Latin America, India, and China. And then we count on the largest agent network into our industry. Here you are the main fact, and this is not just a commercial claim, but this is the pure reality. Over 38 machines installed globally, over 250 new installations every year. And now let's see what are the Nordmechanica solutions for addressing the sustainability and recyclability. I have divided the next sections in three parts: the solvent-based, water-based coating and lamination, solvent-less lamination, and Alox barrier mat coating. Let's start with the solvent-based and water-based lamination. What are the adhesives available on the market nowadays? We can distinguish them in two main categories: the low solid percentage adhesives with 30% of resin and 70% of solvent, or in a high solid concentrate adhesives. For example, 50% of resin and 50% of solvent. And what is our task? Our task is to get the printed web and then to laminate it. And how printing evolves? We have several colors which are combined together in order to get the final image. And if we suppose to get the printing, for example, in a flexo printing unit, we have the white color, the yellow, the blue, the red, and the black. And if we look the web, the clear web, how the printing evolves, first we print the full layer of white, the yellow, the red, the blue, and the black. And at the end, we get our final image. And so what is the task of the lamination and of the adhesive? Is to apply sufficient adhesive or a thickness of the dry adhesive that is sufficient to guarantee the required bond. And if we consider the low solid adhesives, we are applying, for example, 3 grams per square meter. And since this is a 30% solid adhesive, we are requiring 7 grams per square meter of solvent. Likewise, if instead we consider the high solid adhesives, the required dry coating weight is exactly the same, 3 grams per square meter. 3 grams per square meter. Instead, for the solvent, since this is a high solid adhesives, just 3 grams per square meters are required. And so once we coat these adhesives and we pass through the dryer, the solvent evaporates. And so what are the main advantages of the high solid adhesives? We are required 90% less solvent in comparison to the low solid adhesives. And the advantages of these are low energy consumption, better optics of the lamination compound. And in order to apply these high solid adhesives, there are specific trolleys that can be used, the specific coating heads. And these coating heads, one of these are the Nordmechanica Semiflexo. Nordmechanica Semiflexo is made of one rubber roller, one steel chromium coating roller, and one impression roller. The rubber roller collects the adhesive from the adhesive tray and transfer the adhesive to the steel chromium coating roller. The beauty of this trolley is that both the rubber roller and the steel chromium roller are smooth roller. By simply playing with the speed of these two rollers, is possible to adjust the coating weight. Here you are the beauty. So this is what we have just described. If we play with the speed, we can change the coating weight. And with the semi-flexo, it's also possible to work in a counter rotation in order to apply higher coating weights. Apart the semi-flexo, we do also have in our portfolio the flexo coating 5 roller. And how does these systems work? Here we have a rubber roller, a ceramic engraved analogs, rubber plate sleeve, and a metallic sleeve. Here, both the rubber roller and the ceramic analogs are dipped inside the adhesive. Both the roller collects the adhesive, and here there is the first gap, the first calibration of the adhesive thickness. Then there is a second calibration between the ceramic analogs and the plate cylinder, and then the adhesive is transferred directly to the web. Again, even this roller is addressed for a high solid adhesives. Then, what are the main factor in a dry laminator for solvent base and water base? The drying efficiency, the coating technology know-how, the integral stainless steel design, and independent chambers. And this is all for the solvent base and water base. Let's now move to the solventless. Back in 1982, Nord Mechanica introduced to the conversion industry the most innovative, the most advanced, and the most reliable solventless coating head, the Nord Mechanica patent 5-roller system, a system that delivering high quality, consistency of the coating weight, and simplicity of the use became, and it is still today, the benchmark in the industry. And a proof of this benchmark are the thousands and thousands installations worldwide. And here you are the copy, the patent that Nord Mechanica filed back in early 80s. And how does the Nord Mechanica 5-roller systems work? Here we have 2 metering roller, transfer roller B, solid type, coating roller, and the impression roller. The solventless adhesives, made of 2 components, the resin and the hardener, are delivered between the 2 metering roller, and here there is the first calibration. From this calibration, we have the second calibration between the metering roller and the transfer roller B, and finally we have the third calibration of the fine tuning of the coating weights between the transfer roller B and the coating roller. The beauty of this system is that the coating weight is in function of the rotating speed. And the Nord Mechanica patent system delivers the highest accuracy available on the market. And what are the advantages of the solventless lamination addressing the sustainability and the recyclability? First of all, lower production cost. Since there is no dryer involved in the solventless lamination, there are low capital investment, low energy consumption, and absolutely no solvent required. On the other hand, the solventless adhesives requires low coating weight and delivers higher productivity. And since there is no solvent involvement, there are absolutely no risk of the solvent retention. There are no fire and explosion risks. The overall quality is easy to control. What are the technology and the equipment that Nord Mechanica has provided to the industry with these high-end technologies? First of all, the triplex solventless one-shot, which is an award-winning technology that allows to make a 3-ply lamination in solventless in one go. Here you are the web path of this machine. What we have? A primary unwinder, which gets unwinded. And here we have the coating station number 1, where we apply the solventless adhesive 1. Then we have the secondary unwinder, and here we apply the second solventless adhesive. And then we have the third unwinder. All these 3 webs travel together and are laminated in one shot, finishing up at the rewinder. Here you are another example, the duplex one-shot, another Nord Mechanica award-winning technology, which has been brought to the industry in collaboration with Dow, with the Symbiox technology. And how does these machines work? Here we have again two coating sections. But the key feature of this machine is that the two components of the solvent-less adhesive, the resin and the hardener, are applied on two different coating sections. So there are no mixing unit involved. The resin and the hardener are applied onto separate head and are mixed together at the laminating unit. And here, after the laminating unit, the reel finish up at the rewinder. The key advantages, the key feature of this technology is that it allows to move to the next conversion process, so from the lamination to the slitter in 90 minutes. And this is guaranteed. And here you are the last example, the latest introduced in our Simplex family, the Super Simplex E800, a machine that has been designed, conceived, and engineered in cooperation with HP Indigo. The name of this machine, E800, in millimeter stands for the web width of this machine, which is intended to serve the typical web width of the digital presses. Again, addressing the sustainability as the digital factories require for. And now let's move to the allox and barrier mat coating from Nordmechanica Metallized division. So what are the classical three-ply lamination webs? We have the printed web, which could be the paper, polyester, BOPP, nylon, and the properties of these webs are the heat resistance and stiffness. Then we have the middle layer, the second layer, the barrier. And here, this could be aluminum foil, polyester metallized, polyester allox, and the property of these barrier webs are protection from light and barrier and water. And then we have the third web, the sealant web, typically the LDPE or the CPP, which has the heat sealability properties. So what do we have to do in order to address the recyclability? We need to redesign the conventional three-ply in a single polymer structures. And how can be this done? For example, we have the printed polypropylene, metallized polyester, and polyethylene. So from the multi-layer, we can go to our polyolefin structure. So we substitute the metallized polyester with the metallized BOPP. Or we can go from the multi-layer to all two-ply BOPP. Or we can even go from a multi-layer to all polyethylene structure. So what are the aim of this new design? The standard three-ply structure is not recyclable. But if instead we move to a single polymer structure wherever it is possible, so two-ply all BOPP or two-ply all PE, the structures becomes recyclable. And the main challenge nowadays is to transfer the barrier properties from the standard ply to the new recyclable structures. And so what are the technology that are available in order to address this sustainability? The barrier mat. The barrier mat is an oxide layer which is interposed between the polymer and the metal barrier layer. The advantages of the barrier mats are two. First of all, it increases the barrier properties of the web. And the second is that it increases the metal adhesion properties on the fab. Another technology is the allox. Allox is a reactive evaporation process. Here, what we have is a combination and a reactive evaporation between the aluminum evaporation and the oxygen injection. The combination of these two generates aluminum oxidation. And this aluminum oxidation condensate on the film substrate, generating a clear barrier web. If on one hand, the allox increase, or better, it delivers excellent oxygen and water barrier properties, on other hand, it's in a very fragile structure. And so on the market, there are also available top coatings that increase the metal protection of the allox, and on the other side, it significantly increases the barrier properties of the allox coated web. With Normeccanica portfolio, we are able to deliver the depositing of the allox, the top coating for the protection, and finish up for the lamination. And this is all for my presentation. For any further contact or news, please contact the Corvette Technology, which is our local agents in Malaysia, Mr. Kiel Yao, the Managing Director of Corvette Technology, and Mr. Tony Yao, which is the Sales Manager at the Corvette Technology. Thank you all.
Thank you very much, Sinor Govinderjit Singh. That's a very interesting presentation. That's a very good presentation, actually. It's basically revealed to us how we're going to tackle the sustainability issue moving forward. Next, we have with us Dr. Christoph Litorski. He's the Senior Product Manager of Reifenhauser Blown Film. He started as a scientific engineer and a project manager in November 2000 in Reifenhauser. He was, before he joined Reifenhauser, he was the head of injection molding department of a injection molding company from 2005 to 2008. He joined the old Kiefel extrusion in Worms, Germany. I've got the privilege of visiting that plant, where he worked as an assistant to management. He studied mechanical engineering at RWTH Aachen University in Germany. Prior to that, he was at the Institute of Plastic Processing, or IKW, in Aachen. Without further ado, we invite Dr. Christoph Litorski for his presentation. Thank you.
Thank you, Alvin, for the introduction. Well, good afternoon, ladies and gentlemen. My pleasure to welcome you to my presentation on monomaterial packaging. I hope that everybody can see my screen now, and I hope that it fits to the screen. Is it? Okay.
Yes, all good.
All good.
Dr.
Thank you.
Christoph.
So,
Yeah.
welcome again. Okay. I will start with a short introduction with a spot on recyclable packaging, following on what we do in blown film, what was mentioned already by my colleague from Colinis, Francesco. And well, we heard it already so far. The key is really the avoiding of multi-material packaging to make packaging recyclable. And after that, after the short introduction, I would like to focus on ways how to create barrier to oxygen and water vapor transmission for such packagings. And we'll close my presentation on a spot of our technology, how to produce stretch films, stretch PE films, stretch barrier films in a blown film line inline. But first of all, yes, state-of-the-art standard pouches are characterized nowadays by the fact they show a low recyclability due to the multi-material mix, simply due to the fact it's a duplex laminate with a kind of adhesive layer. And the thing is, the crucial thing is the PET, which will make trouble in the recycling operations, although it's offering in nowadays the excellent properties of such kind of packagings, like high quality impression, if you look at the mechanics, its stiffness, its strength, its tear, its puncture resistance. Usually it's converted via reverse print, for example. So it's obvious if we want to take the PET film out, we might need to find a solution and meet these kind of properties as good as possible. And well, one solution is the stretching of PE film with a certain content of HDPE, because if I stretch it like 400, 500, even 600% is not uncommon from primary thickness, say 130, 120 microns, down in a range of 20 to 25 microns, the nature of the film is changing. I get very good optic properties. I improve the stiffness, the strength of the film, and I get a quite stiff film, which is convertible either by flexo or by rotogravure printing. So by doing so, I get a film which I can use for the PET replacement, and I can create a fully recyclable stand-up pouch like this one, which I hope you can see it a little bit at least, which has very good mechanical properties. See the A modulus in and transfers to the machine direction of 1,500, 1,600. For sure, it's not as good as we have the E modulus, for example, for PET, which is well above 3,500 up to 4,500, but it's still good enough to meet the properties of such kind of pouches. The haze of the film is quite good. It's like a 6.5. So obviously a good and nice solution replacing PET. But if we talk about water vapor transmission rate and especially oxidant, you see that is not does not offer good barrier properties. So if we talk about replacing solutions where nowadays high barriers are required, these laminates are usually made of, again, a PE sealing film, but a metallized PET or aluminum and some bio-PET or bio-PP film. So really a triplex solution, a multi-material solution, which makes it a little bit more takes a little bit more work to replace the metallized PET and the bio-PET or bio-PP in order to come again to an recyclable pouch made of polyethylene mainly. So if you look for a monomaterial packaging with a barrier, this means avoid the aluminum, use polyethylene mainly, and create barriers like by metallizing, by ALOX or ZOX technology, or by a very low content of EVOH, wherein one usually says that the content of EVOH should be less than 5% in total in order to give or to name it being recyclable. So the EVOH layer in such pouches shall be very thin. Solutions of all PET or all polypropylene monomaterial are possible in principle, but the challenge here is meeting the puncture resistance and the sealing properties for lots of kinds of packages. So a solution based on PE is favorable. Whereas one has to say that polypropylene can be interesting, in particular for application which require hot sterilization processes. But coming back to PE, one has to say it provides excellent sealability, even if it's contaminated, and it's ideal for sealing, for the sealing layer, for packaging of powders, solids, or liquid products. So one has to think about the barrier, and this can be done via metallizing, ZIRX, ALOX, or EVH, depending on the requirements. And that's the most important thing. If we talk about monomaterial solutions with a barrier, we have to talk about the requirements because the different technologies offer different barriers. If we compare here, we have the standard barrier compared to alu packaging, and we see that PP metallized or PET metallized is well in between. So important is knowing your final application, knowing the requirements on oxygen and water vapor transmission, and then one can choose the correct mix of technologies, because there are several. And this is what I'd like to show you with the next slide. At the moment, we don't meet, or at the moment, we have properties with a standard barrier composite made of BioPET, aluminum, and a PE film, like an oxygen and water transmission rate well below 0.01. Unfortunately, not recyclable. So if we look at the standard pouch, I mentioned it in the beginning, which is made of a stretched PE film, film number 1, and a lamination film out of polyethylene. We do not have any kind of barrier properties. So what can we do to create barrier properties? Well, first of all, is what we can do is do what we do in general blown film packaging, add an EVH into my PE lamination film. Then I get a standard barrier. Film 2 is 7 or 9 layer film. Film 1 is still stretched PO film for the strength, for the stiffness of the pouch. Barrier properties are realized by my lamination film, by the EVH. We can call it recyclable if the content of EVH is well below 5% in this laminate. And then we can create like oxygen and water vapor transmission rates around 5 and 2.1 respectively. However, for certain applications, this is not good enough. So what can we do in the next step to increase and to improve barrier properties? Well, we could, for example, do a metallization of my PE lamination film. So film number 1 is still stretched PE film. Film number 2 is a lamination film with EVH, which is metallized on the surface. Another solution is taking my stretched PE film and add EVH, either in the center, but I can use it also in the outer layer. If I do so, I have to take care of the moisture in order to avoid water absorption. I have to print the backside by rotogravure completely. And the lamination film would be, in this case, a standard lamination film. And to go to the next step, I could even metallize this standard lamination film. And I will give you now in the next 2 slides some idea of the water vapor transmission rate and the oxygen transmission rate of these 2 kind of solutions, where I stretch EVH in a MOPE structure. This is an experimental sample out of the Reifenhauser lab, the transparent film. It's a laminate of stretched PE with EVOH in the outside layer and a PE lamination film. The total thickness of this film is like 90 microns. So PE was 30 and EVOH was 60 microns. And the stretch ratio of a stretched film of the PE EVOH 5-layer film was like 5.5. And we were able, by doing so, reducing the oxygen and the water vapor transmission rate for the oxygen below 1, but for the water, we are still well above 1. So question comes up, what can I do if I need even better water vapor transmission rates? Well, very simple, metallize the PE film. So again, we have a stretched 5-layer film, PE and EVOH, like we had in the example before. But we took the PE lamination film, which was a very simple film, 3 layers only, and we metallized it. We came up with a total thickness, in this case, of 70 micron, again, 30 micron for the stretch laminate made of PE and EVOH. And the metallized PE film was like 40 microns, stretch ratio 5.5 for the PE EVOH 5-layer film. And then we end up with oxygen and a water vapor transmission rate for both well below 1, giving some nice barrier properties. And well, if one would go, final remark, one step further, to even improve these impressive numbers, if you compare them, what was our starting point? Our starting point with the old PE pouch was like above 1,000 and above 2.1, and now with some EVOH and metallizing, we could reduce both values well below 1. Very impressive numbers. If I would go next step, one would have to think about ALOX or ZEOX technologies, where we are right now working on in our lab. So maybe the next time I can show you some results on that. So you see, key is stretching polyethylene film for enabling recyclable pouches, either with or without barrier properties. And what is a good solution? Well, Reifenhauser has a solution, which is our ultra stretch, which is the best solution for stretching film. Why is that? Well, for now we have more than 20 years experience of stretching films, and 3 bullet points which came up in the very first days and are still valid today. 3 simple rules. The warmer the film before stretching, the less energy is required in the MDO. Well, this is a no-brainer. But more interesting is the fact that the less crystalline the film, the easier is the stretching, the more the better is the stability of the stretching, the less holes and all those things which you might associate with problems in stretching do occur during the stretching operation. How comes that? Well, a simple example. When we use the offline MDO in the past, it was an easy thing to do stretching if I do the production of the blown film on the first day and immediately do the stretching. If I have a certain period of time between producing the film and doing the stretching, then the process window on the MDO became smaller and smaller. So this is the reason why the inline MDO is more attractive than an offline MDO in terms of production stability of the process. And it is really worth to think about the earliest position where I can do stretching in an MDO film. And I will show you in only one slide where this position is in the blown film line. And third rule, again, important, is that the longer is the annealing time, the better is the shrinkage behavior. So give the film as much time as possible to anneal, to shrink before you wind it up. Well, and if you take these three rules into consideration and rethink what is the best position for an MDO, it's not on top of the winder, it's not somewhere between the turnabout system and the winder. No, it is integrated in the MDO. And this is what is UltraStretch all about. UltraStretch is the solution of Reifenhauser for stretching film. It offers you the advantage of the fact that the film hits the MDO 2.5 times earlier than if it would be the case if the MDO is on top of the winder. So the film has lower crystallinity, and you need less energy to heat it up to stretch the film, and vice versa. The film has all the way down to the winder to anneal, to shrink. Again, 2.5 times longer than you would put the MDO on the level of the first stage, just above the winder. So final conclusion, if we talk about stretching, it's very easy. Position does matter. To give you some ideas of the UltraStretch, well, it is a full-scale MDO with a stretch ratio up to 1:10 in the Holof. These are pictures. The left-hand side is out of our lab, the MDO on top of our blown film line. Left-hand side, right-hand side, you see an MDO ready for shipment to a customer out of our assembly area in Worms. And yeah, you might compare the operator, the smart young guy, with the height of the Holof. Yes, it is a fully MDO with 12 or 10 rollers. It's in a large and a medium size version available, with all needed stages of stretching, rollers for heating, for stretching, for annealing, and for cooling. Each roller is individually driven by a motor and individually heated up to 120 degrees C. And last but not least, yes, it's on top of the MDO line, but it has all features to enable, say, a good and easy and smart operation. So we have a chain for feeding in the film, and with good accessibility for maintenance. You have access to all rollers via the front and the back side of the MDO, and to the upper rollers you have access via this balcony here, which we find on the front side and the back side of the MDO. So this is the UltraStretch, the solution for stretching film, useful for either all PE film to be used in pouches with or without barrier. And well, that's was my presentation on barrier packaging, monomaterials. And yeah, I have to thank you for your kind attention and look forward to answer your questions in the Q&A session. Thank you very much.
Thank you, Dr. Christoph. Do you have another presentation on the biomaterial with MDO?
So we have another presentation, yes, with biomaterials, because biomaterials.
You continue with that, or
I would continue with that if you don't mind.
yeah,
Alvin,
sure.
I would do so.
Yeah. Okay.
Oh,
Yeah.
okay.
It's yours. Thank you.
Well, if we talk about say the future of extrusion and our approaches and solutions for sustainable packaging trends, recyclability is for sure important. We heard 3 presentations already on that topic before, but I will come up with another aspect of sustainable packaging and trends. And this is the use of biomaterials. And again, I will have a short introduction, or I will make a spot on certain biomaterials, on the definitions, because the term itself is sometimes used in certain meanings. I will then focus on 2 types of materials, their properties, and will focus on the second part of my presentation on ways and solutions how to improve material properties of these kind of films, and by doing so, for sure, for the final product and the final use of these solutions. Well, actual applications in biomaterials is like garbage bags. It is fruit and vegetable bags. This is the first 2 ones are very popular in Europe, especially in Spain or in France, where they are not allowed to use plastic bags from based on oil, crude oil. Milchfilm is another example, T-shirt bags, dry food packaging, and in our days now, barrier packaging is in the focus for these kind of materials. But today I would like to focus on these 4 applications left-hand side. But before I will do so, I would like to give a short view on the term and what is beyond the name biopolymers. Because sometimes it's used for different kind of properties of films. So biopolymers is used as a term, can be used as a term that if I'm talking about bio-based materials, or on the question, is it biodegradable or not, or even both. So we have the conventional plastics, fossil-based and non-biodegradable. And on the other hand, we have the bioplastic materials like starch-based blends, which is both bio-based and biodegradable. And we have a second and a third and a fourth group of material, which is like non-biodegradable, but bio-based and biodegradable, but fossil-based. This is just important to know if you talk about biopolymers, that the term can be used for all these 3 kind of groups, and one should keep it in the mind if discussing that. But let's have a look at starch-based films. Basis is renewable raw materials based on corn, potatoes, etc. It is industrial compostable, so it's true biopolymers. But if one look at the applications, one has to say that the appearance is quite hazy. It has a low stiffness, shows high permeable to moisture, but it can be blended with other materials to modify properties. And well, I will show you later on in the next in the next slide what one can do by by machine technology, because these bags have one disadvantage, and this is the elongation if I put some goods in these bags. And the same is true for biopolymers based on copolyesters, which are usually oil-based solutions, but they are still compostable, show more or less the same disadvantages in terms of the properties: hazy appearance, low stiffness, high permeability to moisture, like the starch-based polymers. So what can we do about that? Well, in my previous presentation, we saw the solution for creating or using PE as a material to create properties by stretching 300, 400, even 500, 600% to meet properties, to change properties, so these PE films become a possible solution for the substitution of PET film or bio-PP film. And if we talk about stretching, one can stretch a little bit lower. And this is the way to modify the properties of those biopolymers. So we don't stretch, if I talk now about stretching, I don't talk about 300, 400 or more percentage of stretch. I talk about stretch rate between 70 and 100% of stretching to improve properties of biopolymers, giving them a little bit better appearance and a little bit better mechanical properties. And the tool for doing so is, again, a stretching unit positioned on top of the line. But in this case, we do not need so many rollers like we need in an MDO to stretch 500 or more percent. This was like 10 or 12 rollers. We need something with a little bit less rollers, and this is what we call ultraflat plus haul-off. Position again is on top of the MDO. The reason for that is, again, the fact that we use the first heat, which is in the film already, because the film temperature here in the nib is usually around 60 degrees C. So if I do stretching at 80, 100, 120 degrees C, I have to put in less energy compared to an ordinary position where the film has already cooled down to something like 30, 35 degrees C. So the UltraFlat Plus, this tool for stretching 100% has the same benefits like the Ultra Stretch for stretching at high rates. We use first heat, the film is still amorph, less crystalline, and I need less energy to stretch. This system contains only of 4 stretching rollers, 1, 2, 3, 4 rollers. This is the nib rollers. Here you would have the A-frame. One for heating, a second one for heating, and then I do the stretching between roller 2 and 3, and the last one is used for cooling. And again, each roller has its own temperature circuit. Each roller has its own motor. And stretching range with this unit is between 1 and 100%. And just one fact which I would like to remind, you might heard already of UltraFlat, which is an iron for film to improve flatness. This is for sure included in this device. So if I apply really only 0.5 to 1.5% of stretch, I will reduce camber and get better flatness out of my lamination film, which will allow faster backmaking and faster converting operations. The result of stretching only 1 or 1.5% is this one. This left-hand side, you see a film without an ultra flat or flattening device, without being flattened by stretching 1.5%, and right-hand side, it is you see the film with using or applying an iron function, a function of an iron, to improve flatness of the film. So yeah, you can use it, this unit, stretch only a little bit to improve properties of lamination film. But if you talk about biopolymers, it is really exciting to apply stretch between 10 and 100% to improve strength and stiffness. Because remember, the big disadvantage of those products, of those bags for fruits, etc., in the supermarket, which are made of biopolymers, is the elongation under load. And please compare now the numbers of the film, which is non-stretched, 12 micron film, with a film which was stretched from 12 to 10 microns, and a film stretched from 12 to 8 microns. And what we see is that we improve the stiffness of the film, we improve the clarity of the film, and we improve the force and reduce the elongation at break. So we improve those disadvantageous properties of those biopolymers by using machine technology. So exciting, we can reduce the thickness, which is usually 12 microns. We down gauge it to 8 microns. We have better properties of the 8 micron film compared to the non-stretched 12 micron film. And yeah, the exciting thing is about down gauging and getting better mechanical properties. About 40% is the saving of materials. And there's one thing which I have to tell you, and was mentioned already in one of the in the presentation of Colinis, of Francesco. If we stretch the film, I will get something which is called bone effect. Unfortunately, the stretch effect, stretching, does not occur evenly across the whole width of the film. Common problem is necking and thicker edges. And if I make bags, I cannot cut away the edges. There's no way to do so. Unfortunately, it is above 20% thicker. So I have to take care of this, the left-hand side and the right-hand side of my tube. Again, trim is not possible because I'm making bags, I have application for bags. And we found a solution for that, which we call edge control system, where we apply some heat just before the collapsing frame under the haul-off, where we warm up the edges of the film and reduce, by doing so, the thick spots at the edges. And by doing so, we can realize big rolls of materials by reducing this thick edge, the bone effect. And well, with this comment on a solution for the thick edges for tube film, for stretched tube film, I would like to close my presentation and say thank you again for your attention. Thank you.
Thank you very much for sharing, especially your data on the OTR, oxygen transfer rate, and also the vapor transmission rate that you have. It's very informative. It looks like we are set and ready to have a mono material. Those numbers match even that of aluminum foil. It looks a possibility. It looks like a a reality that we can have a mono material moving forward. Also, thank you for letting us know that we can stretch the biomaterials, which are always very soft, to make it stiff and better mechanical properties. Thank you, Dr. Christoph. Thank you. Next, we have Miss Wibun Kiao Kemratsani, also better known in the industry as Nick. She's the sales manager in Asia Pacific for Bob's. She has 13 years of experience in the flexible packaging industry, and prior to joining Bob's, she was with Rickman Thailand. Nick has a master's degree in business administration and a bachelor's of science in printing and packaging technology. Wow, from King Mongkut University of Technology in Thonburi, Thailand. Welcome our ever jovial Nick. Over to you, Nick.
Thanks a lot, Mr. Elvin. So good afternoon, everybody, and Salamat Patang, right, to my Malaysian team. First of all, thanks for the MPMA to invite us to join this webinar. And I would like to share my presentation. Just a moment.
Yeah. Sorry, Miss Nick, you're muted.
Yeah, so now everybody can see my presentation.
Yes.
Okay, so today I would like to indicate my presentation for the printing technology on the print on both MDO with the Gravia and Flexo technology. So some of you may don't know both yet. Let me introduce. We are the one of the world leader supplier for the substrate processing, printing and converting machine and services for the flexible packaging, film, label, floating carton, and corrugated board. Company founded in 1890 by Mr. Joseph Bob's, our headquarters in Lausanne, Switzerland. Bob presents in more than 50 countries, employ more than 5,600 people around the world. Last year, our firm recorded turnover is 1.3 billion Swiss francs. With more than 130 years specialists on the experience, with Bob provide the machinery, solution, and technical expertise to ensure our business partner can drive quality, performance, and productivity in their packaging operation. So our six plant, so you can see that in the left-hand side, our facility of the CI Flexo in Bad Bielefeld, Germany. And our inline Flexo is in the Firenze, Italy. Our rotogravure, laminating, and the coating in Bob's Italy and Bob Changzhou in China. And the vacuum metallizer machine we have in the Bob's Manchester in UK. And this in the right is our headquarters in Switzerland. So our industrial now, we move our company on focus away from the being traditional machinery and solution provider to a complete end-to-end along the entire of change. But our industrial vision, we focus the full packaging chain. On the left-hand side, you can find that we cooperate a lot with the brand owner, their designer, pre-press, and also the ink supplier, also converter, retailer, until the consumer. Both we deliver more than the printing machine and services. We develop the software to ensure that the connectivity provide business consultant and help our customer to develop a new innovative business model. So this is our company vision. We translate from the company and the trend to be the connectivity, digitalization, automation, and sustainability. For the connectivity, our machine tooling system is also can talk to each other. And we also can work on the cloud-based system to transmitting the data. Our aim to be in the future of the factory that we also customer can provide the PDF file and also can be the end app, the end product. Our automation is mean that we have smart robotic and smart sensor system to perform our operation with the increased quality, save time, manpower, and cost. So to come to the topic, challenge of the MDOPE. Everybody now talking about the sustainability, and the word sustainability is moved very quick to the strategic part of our business. And end of 2025 is no longer that far away. The solution and application that are ready to be recycled, sustainable, monomaterial, barrier solution, and thinner packaging. We know that the leading brand converter and packaging company have made an important commitment to reach 100% reusable, recyclable, and compostable packaging by 2025. And monomaterial, monolaminator structure like RPE or RPP is creating the best condition for a real and maximum recycling. So you can see that our solution with the 3 pillars, Bob is more focused on the monomaterial on both PP and the PE. Bob is also one of the European Association CFREC. We also the member together with 160 companies and organizations in Europe to the same commitment to collect all the flexible packaging and to channel over 80% of the recycled material into valuable new material and application. There are other similar associations in America and in Asia to have all common objective fundamental to bring the finished plastic back to the packaging loop. You can see in the right-hand side that we are talking more on the monomaterial because the model is more compatible with the recycled plastic. The challenge of the MDOPE we found in the 3 dimensions. First is the surface polarity. And secondly is the thermosensitivity. And the last one is the web handling. How to improve the adhesion of the MDOPE. We found that during the coating phase, some of challenge of the poor surface energy of the MDOPE is had low polarity. The dye level of the MDOPE is around 40. And therefore the surface need to be properly refreshed to achieve a good adhesion between the polymer layer and the bed film. The function of the primer layer enhance both of oxygen and water vapor barrier, but more so for the oxygen, since the barrier against water vapor will be promoted by our metallizing process with allox or silox. Provide a good platform and polar surface of the deposition and the adhesion of a subsequent metal layer, and to help to improve the adhesion onto the bed film. There are several chemistry available in the market. However, the best-in-class coating is the one that is able to meet all those requirements. The MDOPE has a tendency to get the attendance, especially upon the combined application and heat and tension in the dryer. For instance, on the printing side, we also make sure that our MDOPE film will not stretchable and also not shrink during the processing. On our rotogravure, we are ensuring that the substrate that to put on the machine can handling and with the best print performance on the MDOPE film. Thanks to our Bob Lichtenstein, we have a high performance with the high speed of the double site registration control system. And the very accuracy, we talk about that the less than 30 micron for the length and the site registration. And our double scanning head also can read the poor contrast color, even the coating, to ensure that we will get the precise print quality and minimize waste. And we have no waste during the production speed chain or the real splicing. And for the dryer technology, we also have a dual dryer system you can see in the side that our dryer also can come to the front and the back. Especially this kind of dryer, we can reduce a lot of the skin effect and the lower solvent retention. With the lower temperature because MDOPE, we're talking about the production speed like 40 to 45 degrees Celsius to handling the sensitive of the MDOPE film. We ensure that our dryer and the temperature, it will be fit on the sensitive material like the MDOPE. The next one, we talk about the best web handling. We also ensure that our excellent performance to handling the critical substrate. We talk about the MDOPE or even the tin film and also the tin aluminum. Our web handling can handling properly with the very precise. So our experience, we found that the best web handling on the machine is also can help to improve the best print quality as well. Sorry. So this is our performance sample. We're talking about that our rotogravure, we use like the MDOPE 25 micron to print the maximum speed with 500 meters per minute on the rotogravure is also quite critical. But our dryer and our registration control is also help us to improve this. And this is not only the competence sensor model. Our customer nowadays already can print the MDOPE film on our rotogravure already. So CI Flexo. I think for the CI Flexo, most of you already know that the CI Flexo can handle the sensitive material like the LDPE or MDOPE easily. But last year, we launched the new Master CI. Our Master CI is a state-of-the-art machine to include with the advanced technology, advanced robotic system. We also can change the roll and also change the sleeve, analogs, and also doctor bed is automatically to ensure that this machine is also fit and also can digitalize workflow in the future. Our aim to get the file artwork from the customer at the PDF and also deliver with the digital and also twin PDF file to the end user. So this is our technical data. So Master CI, we talk about the 1.3 web width available until 2.2 meter. The maximum speed we have like 800 meter per minute and also can be option of 600 meter per minute. And the prints repeat available at the 370 to 1.25. So I think for the flexible packaging, for the web width like this is already enough. But with the high speed, we also have to ensure that the higher capacity and also the best web handling have to be perfect. With our performance on the Master CI, we talk about the MDOPE 20 micron with the 7 color plus white. We talk about the production speed 800 meter per minute. And I think this one, not only we can handle properly, but with our perfect printing quality is also available on this model. The last one is our Vision CI. Our Vision CI is we call that the smart in price and the best price performance value. The machine also flexibility and sustainability. Our size is very compact design and to ensure that the superior output quality. We also have our smart set that to help to get the good registration on the printing. And our smart heat also can ensure that our heat also can regenerate with the green environment concept. Our technical data on the Vision CI, Our web width available is 920 to 1.5 meter. And our mechanical speed, we talk about 400 meter per minute. Our print cylinder repeat are available at 270 to 1.1, 20 millimeter. This is our performance example on the MDOPE 20 micron. So this one we print on the 7 color together with white in reverse printing. Our mechanical speed is 400 meter per minute. And this machine also can able to print on the LDPE minimum 20 micron. And in case of the OPP, BOPP, COPP, we talk about the 10 micron also possible on this model. So our next one is we call Bob one barrier. Bob one barrier, you also can see that for the mono material, we try to use that the PE and EVOH free to be fully recycled. And for the structure and the detail, my colleague, Mr. Lucas, will discuss more on the 23rd of November because he will share on his subject on the coating and metallizing on this kind of the one barrier monomaterial application. So in summary, all the entire of packaging chain, brand owner, agency, converter, retailer, and consumer. With our advanced technologies, advanced robotic, and digitalized production workflow on Bob Beckham metallizer, printing machine, rotogravure, and flexo printing, with emerging a new substrate such as MDOPE, PP, VOPE, BOPP, CPP, which for a new monomaterial recycled packaging, coating and laminating technology. We have a know-how, we have a capability, and we have ability to support you in every step. That's why we are the right partner for you together to conquer the new business growth together. Oh, last. Once again, thank you a lot for attending, and please feel free to drop me the question and the email to ask further more detail.
Thank you very much, Nick.
Yeah, and now it's back to Erwin.
Thank you, Nick.
Yeah.
Looks like we have to wait until the 23rd of November to listen to Lucas.
Yes, because he will discuss more on the film structure and also one barrier solution what Bob developed together to get the fully recycled. Because he will more focus on the laminator side, coating, and vacuum metallizer.
Okay, thank you very much, Nick.
Yeah, thanks a lot, Erwin.
All right. Next, we have with us Mr. Marcus Pirlik. He's the regional manager, technical sales of Windmoller and Hoscher. He started his career with W&H in 2014 in the Department of Cast Film Extrusion, where he was responsible for Southeast Asian, Indian, and African markets. He studied mechanical engineering and business administration at the Rheinisch Westtausche Technik, Hochschule Aachen, Germany, RWTH in short. Over to you, Mr. Pirlik.
Yes, hello. I hope I'm audible.
Yes, you look good.
Perfect, great. So first of all, thanks, warm welcome also from my side, from Germany, Lengerich, and of course, thanks to the entire MPMA team for giving us the opportunity to have a speech here in front of this great audience. Yes, my topic of today, and I will start sharing right now, and I hope my screen is visible as well. Please just give me a short feedback on that.
Yes, we can see the slides.
Great, perfect. So thanks again. Yes, my topic for today are sustainable cast PP packaging and technology solutions, where I would like to start off with a short introduction and thoughts on sustainability. pretty much all of us know the narrative of the ice bear and the plastic in the ocean. Generally, despite the corona crisis, which we all face right now, the debate primarily, or the sustainability debate, is primarily driving the future actions in the entire plastic industry, right? Nevertheless, the public discussion often is mixing those two pictures of the ice bear and the CO2 pollution and that animals do to plastic waste. Both are important, but it's also very important not to play these two topics against each other, right? So both aspects are important, cannot be played against each other, and we have to make sure, and particularly in plastics, that plastics can be a part of the solution and help the entire sustainability discussion. Just short, but I believe most of you all know that narrative as well here, that the potential for plastic packagings are huge. It's nothing which is protecting goods as efficiently as a plastic packaging. You know, if you look at that screen or that chart showing that 1 kg of glass can hold 1.4 kg of products. Vice versa, you have 1 kg of plastics, which can protect about 56 kg of product. So the potentials are great, and plastics, again, being part of the solution is a good idea, as it is. Also, when we look about growth and urbanization, which lead to challenges, the transport distances are increasing, the transport volumes are increasing. Also here, in that respect, plastic packagings have a huge potential to help the entire sustainability discussion. And looking at each person on average, if we assume that each person is causing 9.7 tons of CO2 emissions on average, plastics do not have that big extent in that calculation. Still, with 0.1, it's rather small compared for each individual person. Nevertheless, due to the about 8 billion people we are on that planet, it's still very valid, and it's super important that also, as a manufacturer or being part of the industry, we are developing new solutions in order to reduce further the CO2 footprint all over the industry. So basically, our 3 fields of action at Windmill and Hölscher in terms of sustainability are the ones which you see here. We are summarizing our actions in 3 categories. We have packaging 4.2 solutions, where we integrate the new IoT systems in the production environment in order to make them more efficient. We have efficient production as it is, meaning we have production of films, today particularly on cast film, and we are trying to make that production as efficient as possible, of course, to reduce the CO2 footprint and reduce wastage. And of course, we are also very interested in partnering up in the industry and developing sustainable solutions, make demonstrators, and also make ourselves think about what can be potential packaging solutions which help the industry to be more sustainable. And of course, what can we do on the machinery side in order to be able to produce such kind of films. Today, I would like to give a short example in each category for everyone, and just guide you through, of course, today with respect on cast film. And I'm happy to listen to a lot of questions in the end, if there are any. So starting with sustainable products, I would like to give you a brief overview about a all PP solution, where we talk about the typical standard pouch. Most of you know that the typical standard pouch is a 3-ply system, usually existing or made out of a counterprinted BOPET or BOPP film, which is laminated against aluminum, a barrier layer, which is consequently laminated against a sealing layer to perform and to enable the sealing properties. The problem with that structure, I think, are obvious. PET in the recycle stream is a problem, as well as solid aluminum, and PET, PP cannot be blended. Hence, there are ideas on how to overcome that packaging to make it a mono material structure. So one of the solutions we have been thinking about is, of course, as it's very close to close ideas, to replace a 3-ply product, which is a blend of different resins, with a 2-ply product, which just consists of polyprop, right? Basically, the idea is to have a counter-printed BOPP film, right, which is giving the optics for the printability and the heat resistance for the packaging process, and barrier layer, metallization or an oxide barrier layer, which can be coated on a liner or a base film, which would be a 60 micron, for instance, cast BP film from our machine, the Filmex, which has an integrated barrier layer to improve the overall barrier properties as it is, right? It provides next to good barrier as well good sealing, and of course, adjusted low COF or whatever is required for downstream packaging machines. So not just on the paper, but actually we launched that product for the last K, and we made a demonstrator with partners and made the first attempt to try to prove that this kind of packaging is possible, and it is possible, right? Of course, there's still some R&D to be made. We are looking still forward a little bit to optimize that structures, but all in all, you can convert existing 3-ply structures with 2-ply structures, or let's say blended structures with monomaterial structures, right? The biggest question is, of course, how to, if these solutions can be, where can these solutions be taken, right? And which applications are they viable? Where do they make sense? And is it possible to produce them as efficient as possible as well? So coming to the production point of view, right? When we talk about producing films, producing multi-layer structures, we talk about the cast process now as it is. And basically, I would say this applies, or this basic thoughts here apply to all production processes in terms of how do you define the sustainability of a process as it is. So we have basically 2 variables which are important in that regard. One of those is using the production time you have in terms of efficiency, right? The more uptime you have, the better it is for the process and the efficiency of the system. And of course, the properties, the more film is in spec, the less claims or whatever you have, and the better it is for downstream application or for selling the film, of course, or converting it internally whatsoever, right? So both coming together, if downtime is increased or film properties are not achieved, resources are basically where since a lot of years how to increase production efficiency, how to make our machines better, how to guarantee that film quality is always in spec and is always consistent, right? It's particular in the cast environment production, we looked close, or we also face a lot of challenges, which not just come from the environment, but also from the market itself. So in today's market, you have to be more and more competitive. Markets are growing, they are maturing, and basically, as we see it globally, the typical drive towards larger film varieties, different products, different setups, is driving more and more. Job lengths are reduced, etc. So I believe that most of you all know that phenomena, and hence in cast, one of the key points would be, in order to react on that changing market requirements, you have to be flexible, you have to be quick, you have to adopt very fast. When we talk about a large film variety demand, right, we particularly also talk about different formats or different decals, right? So in cast, super typical it is that you run a given product or a given job for a certain amount of time, and then the next job has a different width. Super simple. It happens actually quite a lot in cast film that you might change your machine size or the width of the machine, once or twice a day, sometimes more, sometimes less. Nevertheless, if you look at that particular case, that if you want to change the width of your machine in order to change to a new job, yeah, you have quite a challenge if you want to do it old school, I would say. So what you have to do is line up pretty much here. And in order to perform a changeover in terms of width, you would have to slow down the machine, you would have to shut down the machine, and you have a lot of manual work involved in order to, first of all, change the width mechanically on the die, and back again to start up the machine, to bring the machine in production specs, and to make sure that you start up with a good reel. So all the work involved takes a lot of time. All the machine running time in order until the machine is back in specs, meaning you start up the process, you have to make sure your profile is good. It just takes time. If we look in the market or typical values we get from the market, you are ending up with approximately 60, 90 minutes of setup time, sometimes less, sometimes more, which is a rough indication of how much time you need for a job change, right? That time you use, right, is wasted time. The time you're producing, trying to put your machine in spec is wasted time and resources. So one of the long-term developments we looked forward is to somehow overcome these issues, to automate that process, to give our customers a chance to be more efficient, particularly in changes and job changes, not just width changes, but also other changes like gauge changes or whatsoever, recipe changes, for instance. So what seems to be straightforward was, it's not that easy, I would have to say. So we put a lot of brains into it. We partnered up with a company, Claren. We had a development for, I would say, over 2 years with a lot of prototyping, and could launch our die control wizard, our solution for that issues or for that problems, for the challenges in daily production in the last K 2019. So the system or the innovation we presented, we called die control wizard. More or less, it is a fully automated system, right? Able to perform a width change, not in 90 minutes, but in less than 20, with the least amount of operator interference, right? So basically, you change the width by the press of a button. I myself actually tried it in our technical lab. Our process engineer schooled us, which is funny because I wasn't able to manage a product changeover in 10 minutes. After I tried 2 times, it was pretty straightforward how to do that job. So if I can do it in a short amount of time, it's actually something which I believe everybody can learn, and it is super perfect. Once you know how it works, the amount of time you are spending and wasting is reduced to a minimum, right? So you are reducing a big amount cost involved and scrap involved, and you increase your production yield as you have more time in being in good production. So that simple rule applying to most of the customers, or talking to a lot of customers in CPP production, was more or less a small game changer in their production. It is, and I believe we have over 80 systems now in the market, which is quite a good count, and the market feedback is quite positive. So we're still working on improving that system, but it is actually working very, very well. So I'm happy to show that to you all, to all of you guys in our technical lab. If you have time, please come around. Also via digital, right? Some people don't believe that it's working. Yeah, it's working. It's working. I show it to you. So let us know if you're interested to see that system live in operation. Okay, so next to the obvious advantages you have from such a system, you have secondary advantages which are super important as well, or in my opinion actually count more. You're very operator independent. You're eliminating a lot of manual work. Manual work always involves the risk of any, let's say, defects or any critical things you can do in production. Hence, you reduce that risk to a minimum, and you increase the speed and the consistency of your production tremendously, right? So you are aiding the entire topic of a waste efficiency increase and quality increase at the same time. And that is unique in the market, I think, throughout the planet, I would say. So this would be our topic in terms of efficient production. I would like to go over to our last point for today's presentation, which are packaging 4.0 solutions. Also short thoughts on that. So why are data analytics important? Right, data analytics are important to understand correlations between different process steps or process variables, right, which grant you a better process know-how. So correlations which were hidden, like the one you see here, correlation between mozzarella cheese consumption and the amount of doctorates awarded, right? The correlation nobody would have seen, right? But in order to find such kind of correlations, you need a lot of data. It doesn't say that that correlation is true, right? That really because you eat a little bit more mozzarella, you can get a doctor. But that's not what I want to say. I want to say that the correlations in the systems, in the machines is there, or they are not seen, and enabling you to see that or correlate different trends or correlations to find them right. You need a lot of data, which can consequently improve your process know-how, which can improve your production, and which can improve and identify quality topics, right? So in order to have that amount of data, right, you need a lot of data. You need to collect a lot of data, which is not just on one level, but on different kinds of level, on different machines. You also have to make sure that these data can be exchanged. Hence, you need something which is fulfilling that particular job. For that, we launched our RiviGo platform, one platform for all machines in your production, connecting all machines, if it's extrusion, if it's printing, or even converting machines, in one platform. This platform is collecting the data. This platform enables you to visualize, collect, and structure the data you are getting. And I'm not kidding if I say you make millions of different data points every month in your production. So there's quite a lot of volume or traffic happening here. So a system now interpreting that is quite a helpful tool. And based on that data platform, we are developing extensions for each particular production environment. Today, of course, we talk about a little bit about extrusion, but generally, right, once you have the data, you have to find a way to make it usable for you, not just to visualize, but also to enhance your production with different things. Here we are in constant development of our extension to bring them to the next level. Of course, somewhere down the road, we talk about a full automated machine where the computer is telling the machine how to adjust itself, right? Future music, what ambitious goal, maybe we can get there in time. But let's stay at the beginning, step by step first. So with our RubyGain extension, which is built on the RubyGo platform, right? You can automate and supervise your process data. Here, we enable the customer to set boundary conditions and define process setups for different production scenario. As you see here, you can, let's say, choose a range for a certain value, which has to be in spec, right? Once the production process gets out of that boundaries, right, you will get an alarm and the process operator knows, oh, something's happening in the process, I have to intervene, right? So this automatic monitoring can be done. You can play with a lot of correlations. You have an overview about your production setup, and you can learn from past production runs in order to improve your efficiency even more. So here we are happy also from the feedback from our customers, helping in terms of quality and in terms of production, and actually enabling customers to see things which they have not seen before. Basically, to summarize that topic, right, within the sustainability discussion, yeah, it is important and crucial that all parties, including the machine supplier, as well as all other parties, are thriving towards a better future. There's no question that we have to do something with our planet. And in that respect, you know, taking the opportunities in all that action fields we just mentioned is in terms of increasing the efficiency of production, or thinking about new solutions for the packaging market, or is also using the potentials of the IoT systems or packaging 4.0 solutions is crucial, and is something which has to be followed in order to make the world a better place. Great. pretty simple. So I will be at the end of my presentation. Thanks a lot for the audience. If there are any questions, I'm happy to talk about that.
Thank you very much, Marcus. That is very interesting. We can see how you guys are moving with big data in terms of artificial intelligence, I think, moving forward with the Ruby system. It's very interesting. Perhaps I have the privilege of shooting you the first questions.
Oh my goodness.
With your all sustainability PP solution, are we moving from a conventional 3-layer structure, for example, in a pouch situation where you mentioned just now, on a printing layer, barrier layer, and a sealing layer structure, to a 2-layer solution with BOPP and the oriented PP taking over the barrier as well as the sealing layer?
Correct. It's one of the ideas. Yes, correct.
So, okay, so we move on to the first question that we have, which is very related. It says here, it's definitely from a brand owner. What are the costs to brand owners? Yeah, should we be expecting moving forward from a BOPAT to a I think this MDO-PE environment? Are we able to achieve a cost-neutral transition in terms of the cost of looking at just the base material? So if you move from a 3-layer structure to a 2-layer structure, how would it affect costs? What do you think, Marcus? Before I pass this question to the others.
Yes. Yeah, it's a very specific question, but from my experience and from what we see, you for sure have a cost impact in any case, right? I mean, we are talking about established structures which have been there in the market for, I don't know, the last 2 or 3 decades, right? And now we are trying to shift. So we always have to be clear that cost will be important, and cost will be maybe higher or lower. Tendency is higher. New solutions, different use of materials, right? Different production steps. And of course, we should not forget that also downstream packaging, right? Packaging machines. If you use a different system, also downstream packaging machines will be affected. So there is for sure an impact. What is very crucial in our discussions with our customers, we say that you cannot just switch one by one. That's not possible, right? You will never be able to replace a BOPET film. BOPET is BOPET. Whatever you do with other resins, not possible to exchange that. The question is always, how close can you get to an existing solutions, right? With the resources you have, right? Under the legislation we are having, okay? And of course, there will be cost and mechanical or optical side effects, I would say.
Mm-hmm. Okay. Do you see the cost moving down with a 2-layer structure in terms of a 3-layer structure? Perhaps this
difficult to say from my end.
Best answered by a converter.
Yeah.
Okay.
For me,
yes.
Difficult to answer for me.
Yeah,
at
sure.
that stage.
What do you think, Dr. Christoph? Because this question is actually directed to you.
Okay. Well, basically, I share the view which Marcus gave us, because first of all, important is if we want to substitute PET, we have to compromise regarding the properties. And if you look at the installed machine bases for BOPAT and BOPP, and look at the processes and the size of the machines and the speeds, one has to say that it will be hard to meet the price for the PET film. That's simply a matter of a fact. But we all will have to pay, that's what I expect, more for a square meter of, say, stretched PE film compared to a BOPAT film. And we will have to compromise on optical and mechanical properties. But the question is, again, the properties of the film, the stretched film, are good enough. That's the important message, are good enough to replace and to meet requirements of which we have for these goods to be placed in the shelf in the supermarket. And yeah, there's a for recyclability, there's a price we have to pay. And look at the installed machine bases for PET film. It's so huge. The productivity of these, it's a well-established process. The productivity of these machines is so high that it will be hard to meet.
Yes, but to buy a BOPET machine, it is much, much more expensive than to buy a MDO P machine, for example.
Well, that's true, but this is true if you look at the one-time invest. If you look at the productivity over the lifetime, and then do the calculation based on euro or dollar per square meter produced film, then it will change.
Correct.
Okay.
The good thing about engineering investments is we talk about not 2 or 3 years, talk about life cycles of 15, 20 years. And it definitely makes sense to look at total costs, if you want to say that word, total costs throughout that entire time, right? And this is where, the benefits are right now with the BOPET processes and the BOPP processes, for sure. Right?
Definitely, that's very true with the German machine. You got to count it over 20 years, perhaps. Yeah, Marcus?
Yeah, for sure. We have machines 30 years old, nice and green, still working. Pretty cool.
Sure. All right. Perhaps Francesco want to address the area of transparency. I think he's got something interesting to compare BOPP, BOPET, and also the CAS MDOP. What's the transparency level that you are able to achieve, Francesco?
Yeah, basically right now it was not really possible to achieve the transparency maybe on the blown film lines or something like that. But now we start producing MDOP on the cast lines, and what we found out when we start is that honestly the level of transparency was not the one that you can achieve in blown. Then also with the help of ExxonMobil, Dow, and so on, so producer of the raw material, we found out the right direction to follow, let me say. And now we have a sample of film that has very, very good transparency, and so printable, and all the things that you thought that there was not were not possible, now let me say that are possible. Of course, this is an embryonal phase of the production, but yeah, haze, gloss, transparency, and so on, you can achieve this. Is the first phase. There is a lot of work to do, but I think that we are in the right direction, and MDOP can be the future, let me say.
Okay, so to address the first question, sorry, go on.
Sorry, Alvin, maybe a comment on my side on optical properties, just to give you an idea. Whereas BOPET and BOPP is well below 3. You usually find values like 2.5, something like that. If you buy that kind of film, one has to say that this is a range which we will not reach with MDOP film, where I would say a value between 9 and 5 is realistic somehow. But again, keep in mind that you take the PET film and do the lamination to a lamination film, blown film, for example. And then if you look at the total haze of these laminate, of this structure, and then we have the question, is it transparent or is it printed? Then the haze, so the optical properties of the substitute for BOPET or BOPP film are not that important to meet the 3 or 2.5, because important is the optical appearance of the pouch. And due to the fact that you will, if you look at BioPAT in nowadays, and at the pouch, the haze of the pouch is completely different due to the blown film and the glue. So you usually the good optical values of the PET drop dramatically if you look at the finished laminate. This has to be taken into consideration. So it's not, from my point of view, from a technical point of view, but also from a sales point of view, from marketing point of view, it is not important to meet the 3 or 2.5 from as a haze value for the PET film. Because you lose properties when you do the lamination.
Wow,
yeah, exactly. I'm totally agree with him. Yeah.
Oh, that's a very interesting observation. That's only known to converters, perhaps, not to film producers like us. Yeah,
I understand that it is a problem for producer of film. If you do a single comparison of PET film, somebody is buying PET film and says, "I need exactly the same properties of these kind of PET film." No, talk to your converter and look at the final product.
Oh, that's very interesting. Yeah. Okay, we'll keep that in mind. Mr. Chan, we are good with time. What do you want to take a poll or something? I understand before we move on to the next question.
Yes. Okay. Ladies and gentlemen, we would like to do a quick poll to access the webinar. This will help the Secretariat understand the areas of improvement for future webinars. Kindly participate by giving your feedback. We have a total of 8 questions, so please start now.
Okay, we'll take 3 minutes to help Mr. Chan with his poll before we continue with the next question, which is interesting as well. I think today we've got more than 200 participants. I can see from various ASEAN countries, including Vietnam, Myanmar, and also from Thailand, which speaks well for MPMA's effort to attract member countries in ASEAN through the AFPI platform, I suppose.
Alvin, maybe just allow me 10 seconds to say a big thank you to all the speakers for giving us such wonderful technical knowledge on the processing, the materials, the equipment, and so on. I am not a film man, but I think I've learned a lot. Maybe I should go into film, huh?
You should.
So speakers and panelists, thank you so much for your contribution and your help to MPMA to make this webinar a success. Thank you.
Thank you.
Yeah, I'd just like to, Alvin, I'd just like to add on something here. One of the biggest challenges that we have insofar as flexible packaging is the fact is that the flexible packaging is the foundation for single-use plastics. And single-use plastics has been under a lot of pressure, a lot of issues about environment. So it's always a challenge when we deal with the authorities, when we deal with consumers and so on. It's a big, big challenge. Recently, there have been a lot of focus now on climate change, especially on COP26. And the question of climate change and therefore carbon footprint has become much more important. The fact that Marcus came about and presented his opening remarks in his presentation and touched on sustainability and the carbon footprint, I think it's important thing that MPMA is also taking in to be able to demonstrate to the authorities that yes, plastic has its issues on sustainability, on environment in terms of marine litter and so on and so forth, but plastics is part of the solution. In fact, it's a big solution when it comes to climate change. So the fact that the industry is working on down gauging which of course improves on climate change perspective. And more important is that I continue to see a lot of development in the monolayer, monosubstrate type of development that I think is important, because the question of sustainability has always been the question of recyclability. And multiple substrate lamination in the past has been a huge problem when we try to explain to the authorities how we can eliminate the problem of recycling. The fact that you guys are moving in the direction, together with, of course, the material suppliers, upstream material suppliers like Dow, Exxon, and so on, I think that's the direction that we like to see, and I hope to see more of that. So thank you so much for your development, and of course, thank you so much for making this event a success. So over to you, Alvin. Thank you.
Thank you, Dr. Lim Kok Hoon. Dr. Lim is our MPMA president, and Mr. Eddie Fong, you had him just now, is the chairman of PLASTECH 2021. We were guided by their leadership. Thank you very much, sir. Let's move on to question 2. Moving towards mono material PE and PP, which solution is gaining more traction in the market, or both? Both are is dependent on the or is it dependent on the application? I saw just now that Francesco has answered this. Perhaps both are important, PP and PE. PE, of course, with the sealability, would be more popular for applications such as powder or detergent, liquid and oil, cooking oil and all that. Perhaps Dr. Christoph, do you want to take that? Because this question is to you as well. Whether PP or PE, in your opinion, and whether they will clash in a monostructure material.
Well, I think both solutions are exciting, because both go for the same purpose. Sealability is important. I think it's with the PE more exciting, makes it more easier. But we also made trials and collected experience with PP. So we made pouches out of bio PP and a blown PP film, which could be used in the same sense as cast PP film. I think the really interesting question is about the recycling stream. Let's take another perspective, because producing such a pouch is only the first step. The next step is the question: once the pouch is used, single-use plastics, what is the more established recycling stream? Will it be PE or will it be PP? And I think this aspect will have an influence on the question, which is the one which will become more popular in the future. And being able to offer both solutions, I would, with a perspective on the more established recycling stream for polyethylene, I would expect that in the future polyethylene will be the more popular solution. But as I pointed out, from the points of properties like hot sterilization and things like that, there are definitely products where polyethylene will not meet the requirements of the final product. So there will be requirement. There will be. I do not see a cannibalization of one or the other. It will be one next to another. But I expect that the share of polyethylene will be bigger compared to polypropylene.
That helps a lot for filmmakers like us on where to invest. Dr. Christoph, thank you. I think over to Marcus on the PP side. PP is now very popular, for example, with CPP on the sealing layer with biscuits and cookies manufacturer. What do you think, Marcus, moving forward?
In terms of, related to the question you just mentioned, in terms of which is getting more traction?
Yes.
Yes, so pretty much I go along with what Mr. Dr. Christoph Lutowski said. there is, if you include that perspective of the recycling stream, that's completely valid, right? Example, the US, based on polyethylene, there is no PP, right? So it will be a challenge or a question mark if suddenly the entire market will change to polyprop for certain structures. I don't believe that, right? So that particular argument is completely valid and has to be taken into account. General PP, I think the share, as it is already, as of today, there is I believe, a bigger share in polyethylene laminates compared to polyprop, but still both will exist, and there are always limits in both resins from the origin on physics and chemistry. And still polypropylene in the cast process giving solutions which are valid now, which will be valid in the future. And the question is now if we can develop other options or let's say other potentials which can be introduced into the market, right? Going forward into sustainability. But popular for biscuits, yes, why not? I mean, I don't know if just investing in polyethylene is cool.
No, it's probably the cost structure that, you know, people are going for CPP. You've got two very honest answers moving forward from the experts. You heard it all there, ladies and gentlemen. Let's move on to the third question from Nithin Thakur of ExxonMobil. Is there a limitation on package weightage while moving from PET to PE or PP? And how about seal strength data for PP as a sealant versus PE layer? I think PET, PET conventionally will be moving towards 15 microns or 12 microns. And I think MDO PE, you're looking at 20 microns. There's still a huge gap there to narrow. What do you think, Dr. Christoph, in terms of limitation on package weightage?
Let's take the following perspective. If we look at pouches and applications and mechanical properties, I would like to answer the question from that perspective. Yeah, we have the thickness is bigger of the PE film, and I have and don't forget that I have a second film, the PE lamination film, which I can use to adopt the thickness, the properties of the PE film, non-stretched, to meet again the requirements of the pouch. So we made pouches for detergents, for powders, for cheese, for nuts and things like that, which were originally PET was used. And we met the requirements of the final pouch to the weight, and the weight is like, we can go up to, I would say, 800, 500 gram, up to 2 kg. That were the applications we addressed so far, and where we met the requirements by adopting and playing with the thickness of the second film of the PE film. Mm-hmm. So PET has again looking back, I would say for many applications, and it starts with the thickness of with the E modulus, which is like 4,000, 3,000 of PET. And if you look at the tensile strength, we are in machine direction. We have a range of, for example, 200 megapascal, where we meet with the PE film unblocked of 150% stretch of 150 megapascal. So yeah, there is a gap, but for many cases mentioned above, the PET is a little bit over-engineered. And if I really need a little bit more of mechanical properties, don't forget that I have a second partner within my pouch, where I can again play a little bit with to meet again the requirements I need in the shelf. So we don't meet PET completely, but we are somehow, I would say 75% maybe below in terms of mechanical properties. But to meet the requirements in the shelf, we can play with a second partner. And in many cases, this will be good enough.
Okay, yeah, got it. What about the sealability between PE and PP? Do you have some data for that? The question goes.
PE and PP.
Yes.
Sorry, I have no experience, no data on that, because we try to avoid it. Simply due to the fact it's true, it's all polyethylene pouch, but again, if we put this in a recycling stream, the mix of PE and PP will be difficult to be recycled.
Okay. What about Marcus? Do you have data on the seal strength of PE as a sealant compared to PE?
Yeah, I believe everybody knows there are already natural differences, first of all, due to the process and of course, due to the resin. So in terms of weightage, and this is what the question is here, I'm not the 100% expert. We have data available for different seal strength. We have blown and cast machines, of course. And for higher weights, as still my information as of now is that PE will grant you the higher seal strength. Right, when we look about Southeast Asia, India, big packaging or all packaging pouches, right, the best seal strength you can get is with PE, as of my understanding right now. Polypropylene has other maybe benefits when you talk about SIT, hot take or whatever, but in terms of seal strength and see-through, seal integrity, PE has certain advantages, right? And the question is, of course, how big is the weight, right? What are the other boundary things? And this is always what we try to understand, is not just a single point of view, which is sometimes easy to be answered, but if you look at the whole picture, there are usually more requirements than just sealing, which we usually try to take into account. But to make it simple, as of now, I believe seal strength for weightage, big packaging, PE seems to be still the dominant polymer.
Okay. There we had it, an honest answer is PE again. Wow. Okay, this question is to you again, Marcus, from Yap Jevan from Stanta. When using systems like Filmax and Ruby, are there processing advantages for subsequent metallization or cast PP films? We saw just now you integrate the Ruby between the printers and also the cast line. So what's moving forward?
So generally, there are here two answers. First of all, as an origin, what do we want to achieve with the Ruby system? With the Ruby system, basically, in any process or production process we have here, we want to increase stability of the machine, enhance the process productivity and the quality, right? Which, of course, aiding in general all downstream processes, right? Meaning you have your machine or your recipe in spec, keep it in spec, make sure that it is there in spec. It will aid downstream processing. This is so the general benefit of additional help with such databases and correlations. Second step is, of course, and this is what we will plan, or we are planning to incorporate in our point of view, to connect also downstream processing like metallization in order to see, okay, are there direct links between the metallization process and the cast process, which we can incorporate again in the original process to take care about, right? But this is a little bit future music. We are not there yet, but I strongly believe that there are connections, specifically in tension control whatsoever, where Ruby can help or data analytics can help long term.
Okay, great. Thank you, Marcus. We've got another question here, question 5 from Tony Yao of Corvette. BOPE, wow, that's something I think non-existent yet. Okay, the question is, BOPE has been promoted as a mono materials sustainable packaging. What is the pro and cons of BOPE against MDOPE and the cost? Is it on the blown or cast technology?
Without considering the price.
Yeah, exactly.
Is it
I think that
BOPE?
Yeah, I think that the price is the main problem right now. If
Currently, yes.
Are you
have
guys
a
developing BOPE already?
No.
Francisco? No?
No,
Marcus?
no, I feel
I think there are some resins available in the market, even commercially, but one has to clearly say that they by far don't meet the properties we can achieve with MDO PE in terms of, for example, the modulus. Whereas I would say in machine direction we have like 1,500, 1,700, even 2,000 is possible with MBOPE, whereas BOPP is well below 500, 600 in machine direction. So the mechanical properties are not as good as at the moment what we get in MDO PE. And I think that the interesting question will be if there will be in the future, and it's maybe a question to the resin makers, if they think they will be able to create a polyethylene with very similar behavior of a polypropylene, maybe even PE, which I can process on the installed machine basis in the market for either PET or PP, then it would be very attractive. But I can't comment on the modifications I have to make on existing machine bases, and if they think that they will improve mechanical properties in future. I don't see that from my perspective in the next 3 to 5 years. Beyond that, I don't know. If we look at barrier properties, say integrating EVOH, I think the story becomes different again, and this may be in favor for MDO-PE. So if you buy a machine for PET replacement today, I would go obviously with the blown film line, not only because I'm working for blown film machine producer, but if you want to do that in 5 years, the story might be different.
Yeah, I mean, what for sure has to be done is we are watching, of course, the developments there, right? There is a big name producing BOPP machines, BOPET machines, right? And of course, these guys are developing towards that direction, which is natural, right? I mean, that's, of course, something we would do ourselves, right? So it's right that these guys look into the possibilities. Currently, differences are mainly in mechanics. So I would say mechanics and processability, right? And if resin guys can enhance that situation, we definitely have to watch that closely. Currently, I see that within a short period of time, that will be for sure tough. But long term, I can imagine that you will have a coexisting portfolio of different applications as we have it today, right? I mean, we are using BOPET for print. Sometimes we use BOPP for print. We use sometimes a PE sealing layer, sometimes a PP sealing layer for different kinds of reasons, right? And we are watching that closely. I think testing that is completely valid. If they succeed, it's a different story. And if they succeed for which kind of products or which kind of markets, for which kind of applications will be another question. So yeah, we are in a very, very early stage of pretty much shaking the entire industry of laminates. And we will see in a couple of years what came down and how we reorganize that and which products, laminates came out or been grown, right? So very interesting. We are, of course, watching that closely. If you have more insights, please let us know. Here's my number. Oh, good.
This is a very good platform to enhance discussion.
Yeah, correct.
Yeah. you wouldn't have this platform between the blue and the red.
Yeah, it's all good. You know, we like competition. It's all right.
Okay,
it's cool.
All right, good stuff. Perhaps a last question to Mr. Govinderjit Singh. What do you think of the oxygen transmission rate when you coat it with Alox with a layer of EVOH, which will give it polarity? to the film, to the substrate. What do you think VAV aluminum foil with EVOH and Alox coating? Would it be replacing aluminum foil?
Well, at the moment, we have already done research in that direction. You know, the aluminum is considered as the reference. So oxygen transfer rate and water transfer rate is 0. And then all the other structures get compared on what are the improvement from the market. Yes, EVOH might be one of those structures, but it's not recyclable. So the direction where we are going are to find the BOPP with the Alox, and then on the top of it, the barrier coating, and the same, it's also done on the MDOP with the Alox and top coatings. And with these structures, we are down to reach OTR values in the range of 0.1, 0.2. So really close to what is the market demand. Then it's a matter of transferring the know-how, the technology to the actual laminates compound.
Wow, that's very interesting. That's good enough for coffee.
Yeah.
Okay, that's good enough for me as well. We are 5 minutes over time. I think the organizer would like us to all turn on our web camera to take a picture, and we will end the session accordingly. Thank you very much. Over to you, Mr. Chan.
Yeah, thank you, Mr. Erwin Ang, Mr. Francisco, Mr. Kowinji Singh, Dr. Christoph, Ms. Nick, and Mr. Marcus for presenting at today's webinar. Your willingness to share your time and expertise in this area of flexible packaging trends is much appreciated and indeed timely for the benefit of the industry and success of this webinar and MPMA Plastic Month 2021. Once again, please accept our sincere thanks and appreciation. Before we end today's session, I would request all speakers and the MPMA team, please turn on your webcams so that we can take a group photo.
Oh, that's a lot. Who is taking the picture?
Picture done? Done? Yes, yes. It's done. Okay, once again, thank you for all to our speakers and Mr. Erwin. Have a pleasant evening and stay safe. Thank you.
Thank you very much, everyone.
Thank you, everyone.
Thank you all.
Bye-bye.
Bye-bye.
Thank you,
Bye-bye.
everyone. Bye-bye.